Okay, hello class. This is Math 1430. We're going to review for exam number 3, which is on Monday, November 23rd. So it's going to be this upcoming Monday, exam number 3, and it's to be taken on WebAssign. And the final exam will also be on WebAssign. Okay, and here's what exam number 3 is going to cover. It's going to cover 5.1, 5.2, skip 5.3, that's not on the syllabus, and then 5.4 and 5.5. So I have 5.1 and 5.2 in parentheses because those are just algebra review sections. So really, just gloss over them. But, 5.4 and 5.5, those are derivatives of the log and exponential functions. And then we got also for this test number 3, 6.1, 6.2, 6.3, 6.4, and 6.5. And 6.3 I have in parentheses because we did not have that on WebAssign. And these problems generally take pretty long, so it's unlikely you're going to see a question from 6.3. I'm not going to guarantee it because I don't pick the problems on WebAssign, but I would be surprised, but not shocked, if there's nothing from 6.3. So I put that in parentheses, so de-emphasize that anyway. And 6.3 is all about building rectangles to approximate areas under curves. It takes a long time. So again, I would really not emphasize 5.1, 5.2, and 6.3. Okay, so I just want to go over 2 problems today. Here's the first problem. We want to find the definite integral from 0 to 1 of 3x times e to the 5x squared dx. And then here's the second problem, which I'll do afterward. If f of x is this quotient, the natural log of x squared plus 1 over x squared plus 1, find f prime of x. And I wrote think quotient rule. And note, it looks tempting to do it like a u substitution, but you can only do u substitutions for integrals, not derivatives. So note, u substitutions are for certain integrals only. Okay, and speaking of u substitutions, it looks like this first problem is a perfect candidate. So my brother is going to take over filming.
Hello, it is I. Welcome to Calculus, and let's get started.
Okay, so as I said before, with definite integrals, the first step is just think of the indefinite integral. So and bring this 3 outside. So I'm going to think of this as 3 times the indefinite integral of x e to the 5x squared dx. And I see a product, but product rules are...
dx, not du.
Oh yeah, dx here. So product rules are only for derivatives, not integrals. So when you see a product or a quotient for integrals, very often a u substitution is going to be needed. And in this case, do you see how you have an x squared and over here is an x? When the exponents differ by 1, then typically what you do is you let u equal the expression with the higher exponent. So in this situation, almost always you're going to let u equal the exponent of e. So u is 5x squared. And then, so I'm doing a u substitution for integral here. So then du dx is equal to 10x by the power rule of derivatives. 2 times 5 is 10x. And then you decrease the exponent by 1. And then what I do is solve for dx, but you may do it differently. So I'm going to solve for dx. Let's clear the fraction. Multiply each side by dx to get du as 10x dx. And then to get dx by itself, divide by 10x. So du over 10x is equal to dx. Now that I have it solved for dx, I'm going to rewrite this integral using my substitutions. So I'm going to say this integral here is equal to the integral of, we have no substitution for x, but now let's write e to the u. And then in place of dx, I'm going to write du over 10x. Notice my integral is with respect to u, with the du, so I don't like x's. But if you're doing things correctly, the x's will always cancel. So this bottom x cancels with that top x. So now what we have And this 10 is on the bottom, so think of this as a 1 over 10. I'm going to pull out that constant factor, 1/10 times the integral of just e to the u du. So that's the whole point of u substitution. You begin with a scary looking integral and you end up with a friendly looking integral. So we know the integral of e to the u is just e to the u plus some c. So this is going to be 1/10, and let's do this integral. The integral of e to the u is just e to the u. I'm not going to worry about plus c because ultimately we're doing a definite integral with those limits of integration, 0 to 1. So now what am I going to do next? Replace that u. So this is going to be 1/10 e, and u we said was 5x squared. So you always want to get your answer in terms of x ultimately. Okay, so this is the indefinite integral. This is my answer to the indefinite integral. Now that I have an antiderivative, let's go back to the original problem. What is the definite integral from 0 to 1? So to do this definite integral, the first step is to just find an antiderivative. And that's what we did. Here is the antiderivative. It's 1/10 e to the 5x squared. And now that I have my antiderivative, the second step is to evaluate it from 0 to 1. And then the third step is you want to subtract these evaluations. So this is going to equal, you input the 1 first. So I'm going to write 1/10 e. When x is 1, 1 squared is 1, 5 times 1 is 5. So I'm done with the 1, and then you always go minus, and now you input the lower limit of integration. So when x is 10, you replace it wherever you see x's, you're going to write 0. So let's write the 1/10 again, and then e to the, if x is 0, then I'm going to get 0 squared is 0, 5 times 0 is 0. Don't stop there though, because anything to the 0 power is 1, except for 0 to the 0, which you don't really see too often, because that's indeterminate. So don't worry about that. In general, anything to the 0 power is 1. So this is going to be 1/10 e to the 5th. Don't approximate. Do not approximate unless they ask you to. So this is the exact answer. 1/10 e to the 5th minus e to the 0 is 1. This is just 1. So what's 1/10 times 1? It's 1/10. So you can leave your answer just like that. That's the exact answer. That's the area under the curve. That's a positive number. Or if you want to, you can pull out the 1/10. That's the GCF. And then you're going to be left with e to the 5th minus 1. So either answer is fine. So we're done with that problem. And now let's go to our last problem, our second and last problem. So given this function, we want to find f prime of x. This function is a quotient. So with derivatives, we can do a quotient rule. But remember, don't do any u substitutions for derivatives. It's only for integrals that we do u substitutions. So let me continue up here because there's more room. So here we go. If f of x is equal to this, then f prime of x is equal to, and now we're going to do the quotient rule, low d high minus high d low all over low squared, where high is numerator and low is denominator. So it's going to be low, which is x squared plus 1. Make sure you put it in parentheses, and then times. And now what is the derivative of the numerator? What's the derivative of a log function? So try to remember this. The derivative of a log function is going to be 1 over the argument times the derivative of the argument by the chain rule. So I'm going to write 1 over x squared plus 1 times, and then what is the derivative of this argument? It's going to be 2x plus 0, which is just 2x. So times 2x. So there's my low d high minus high, which is the numerator, ln of x squared plus 1, and then times the derivative of the denominator, times the derivative of this denominator is just 2x. And then don't forget to write all over the denominator squared. So the denominator is x squared plus 1, and then we got to square it. So let's just review what I did here. This was our original function. I used the chain rule to find the derivative. So when you find the derivative, make sure you write f prime of x equals, and it's going to be the low.
You did the quotient rule.
Yeah, the quotient rule I did, right. Okay, so now let's simplify this. And by the way, don't make this a careless mistake. You can't go x squared plus 1 cancels with x squared plus 1, because this is not a factor. This is an argument for the log. It's sacred, so you cannot cancel. Okay, so let's continue here. I'm going to try to simplify this. So this derivative is now going to equal, these are all factors in this first term minus this second term, which is all factors. So the x squared plus 1 on top cancels with this x squared plus 1 on the bottom. And then I'm just left with 1 times 2x. So that first term is just 2x minus, and then these, I'm going to put the 2x in front. It looks nicer that way. So I'm going to write 2x times the natural log of x squared plus 1. And that's going to be all over. And then don't FOIL this out. It's okay to keep the denominator in factored form. So I would just keep it like that, x squared plus 1 all squared. And again, you can't cancel. That would be totally wrong. If you want to, you can pull out the 2x from the numerator. It's not necessary. I'll do it anyway, just in case WebAssign. But I hear WebAssign would probably accept this answer, but just in case. If you take out the 2x, it's going to be 1 for the first term minus, and we took out the 2x, so it's ln of x squared plus 1. And that's going to be all over x squared plus 1 squared.
Done.
Done. Okay, so good night, everyone.